Hello students, we will be doing revision of work and energy today. So we have already done, and I hope you must be preparing well for the exams. So we will be starting with revision of work in this lecture. So what is work? Work is defined as, or work is said to be done. Work is said to be done if a force applied on a body causes displacement. So from the definition it is clear that work done depends on force and work done depends on displacement of the body. So if you combine these two, we can come to a conclusion that work done must be directly proportional to force F and displacement S. So combining these two statements, we can come to a conclusion that work is equal to, or work is directly proportional to Fs. So we get W is equal to Kfs. K can be taken as 1, so we write W is equal to Fs. So mathematically, work can be defined as, mathematically work done can be defined as the product of force and displacement. So W is equal to Fs. So what is the unit of force? Unit of force is Newton and displacement is meter. So SI unit of work is Newton meter, or we also call it as joule, represented as capital J. So 1 joule is equal to 1 Newton multiply 1 meter. Okay. Now let us come to the Cgs unit. Cgs unit of work. What is the Cgs unit of work? It is erg, and 1 joule is equal to 10 power of 7 erg. So let us see how do we get this 10 power of 7 erg. 1 joule is equal to 1 Newton into 1 meter, and this can be written as 10 power of 5 dyne multiply 100 centimeter. So it is 10 power of 7 dyne centimeter. This dyne centimeter is called as erg. So we get 1 joule is equal to 10 power of 7 erg. And what is the nature of work? Work done is a scalar quantity. Scalar quantity means it has only magnitude, but no specific direction. Okay. Now, types of work. In physics, we have got three different types of work. The first one is positive work. The second is negative work. And the third one is zero work. Let us see what is the difference between positive, negative and zero work. The first one is positive work. What do you mean by positive work? If force acting on a body, and the displacement produced are in the same direction, work done is said to be positive. Similarly, now if you look at, we will come to negative work after some time. Let us see some of the examples here. Force and displacement are in the same direction. So if we are having a body, this is the body, we are applying a force F and this is the direction of displacement. So example can be pushing a trolley. When you push a trolley, you can see that the direction in which the trolley moves is same as the direction of force applied. So work done here is positive. Force and displacement must be in the same direction. The second, for a freely falling body, the direction of gravitational force is downwards. The direction of gravitational force is downwards, and the direction of displacement is also downwards. So what is the work done? Work done here, work done would be positive. Okay. So before we go to the negative work, just come back to the formula. 1 joule of work. We have written 1 joule is equal to 1 Newton into 1 meter. So sometimes the question comes, define 1 joule. So what would be the definition? If a force of 1 Newton causes a displacement of 1 meter, work done is said to be 1 joule. Okay. So let us come to negative work. Second one, negative work. What is the definition? Work done is said to be negative. Work done is said to be negative if the force applied and the direction of displacement Force applied and the displacement we can write. We need not write direction of displacement. We can write work done is said to be negative if the force applied and the displacement are opposite to each other. Now if you see the definition, force is acting opposite to displacement, and the best example that comes to our mind is frictional force. We have read in class 8, friction always acts. Frictional force always acts opposite to the direction of motion. So if motion is along the right side, then frictional force would be always towards the left side. So if you see this case, force and displacement are in the opposite direction. Therefore, work done by frictional force is negative. This is first example. Let us see another example. If a ball is thrown upwards, the ball is moving against gravity. So this is the direction of motion, ball moving against gravity. So here in this case, displacement is upwards. Displacement is in the upward direction. What about the direction of gravitational force? Gravitational force is vertically downwards. Gravitational force is vertically downwards. So if you see this case, body is moving up, gravitational force is downwards, displacement is upwards, so work done would be is negative. Okay. Let us come to the third type of work, that is zero work. What is zero work? If the force acting on the body, on a body is perpendicular to the direction of motion, then work done is said to be zero. So for this, let us see an example which is very important for your exams also. A body moving in a circular path. Let us draw a circle. So this is a circle. This is the center. A body is moving in a circular path. So let us say A is the position of the body. When the body is moving in a circular path, what is the direction of motion? The direction of motion of the body is along the tangent, to the circle. So let us draw the tangent. I am using a green pen to draw the tangent here. So AX is the tangent. AX is the tangent. So what is the direction of force here? Force is towards the center. Force is directed towards the center. So force perpendicular to displacement, therefore work done is equal to 0. Now what is the example for this? Work done by a satellite moving in a circular path. The question can be, why is, or what is the work done? What is the work done by a satellite moving around a planet, in circular path? What is the work done? The answer is work done is 0. Why it is 0? Because force is perpendicular to the displacement of the body. Similarly, if you talk about another example, a coolie carrying a load on his head, a coolie carrying a load on his head and walking on the ground. So in this example, direction of displacement is this, and direction of force, gravitational force, is acting downwards. So force is perpendicular to displacement, therefore work done is 0. So we will discuss till here today. In the next video, I will be sending you the revision of energy. Thank you very much.